Okay, so recursion, let me go here and share this screen with you. Look at recursion. So this is, I couldn't find a better definition than from this site. They had a really good definition, I guess, of what recursion is and how do we use recursion in programming. So here, recursion is when a solution to a problem that uses smaller instances of the same problem itself. Okay, a little bit hard to explain, but in terms of programming, recursion is usually referred to when a function that calls itself. Okay, that's the recursion. So another example how recursion can be seen is like the Russian dolls. I'm pretty sure you've seen this already. If you look at it, it's like the bigger version, right? You open it up, you have a smaller version until you find a really simple version of that. So that's an example of what recursion is. It's the same shape, same function, same data, right? Okay, repeating stuff. And then, of course, you see a lot of things in as-well in nature. It's a pattern going on. If you look at the leaves over here, the ferns, like you have going from bigger and smaller version of it. Same thing here as well, and also these. And you can also find in other places, and like seashells and things like that. So a recursive function then is usually referred to when a function that calls itself. Factorial is calculated by you multiplying the number of, let's say, factorial of 5, multiply that by 4, by 3, by 2, all the way to by 1, and you get the product of all. The product of all those numbers, and you get a factorial. And so if you look at it, it's like the Russian doll, right? 5 and 4, 3, 2, 1, smaller and smaller until you get to the smallest number, and then you end there. So when you write a program, you have to establish one or two base cases to terminate the recursion. If you don't do that, then you're going to end up just like an infinite loop, right? And it will crash your program. So this example on the left side is the factorial function to calculate a factorial number. Okay. So the base case will be here. If n is 1, then the result is going to be 1. And I think factorial 1 or 0 will give you 1 anyway. So you can check that because you pass n the number 5 in here. If n is not 5, then you skip the return clause. You go to the next return. And this one says 5 times the factorial of 4, right? 5 times factorial of 4. So 4 goes back into the function. It does it again. Now, what is 4? So 4 times factorial of 3. So you can see how that gets through the whole process until n is reduced to 1. When that is true, it returns 1. When 1 is returned, everything gets reversed. Okay, it recurs back. So it can be very confusing if you're not careful. There's another one that if you or some of you might have used before as an input. Okay, when you write a function to get the input, you call the input function, you ask the user to enter a number, a positive number, for example, and if they enter a negative number, you print invalid, try again. And so if you do not use a while loop in the inside here, and you happen to call the same function again, right? If you do that, it's going to call the function. But if you keep running that cycle indefinitely, eventually you're going to run out of memory, okay? Until you get a valid value, and then it would recurse back. But when it comes back in the data, you're going to get an incorrect number also. So very, very confusing. So this is what's called a recursive call, when you call the function itself within the body of the function. It doesn't matter where, anywhere the function, if it's calling itself, we call that a recursive call, okay? Now remember that every time when you call a function in the program, it doesn't matter if it's Python or Java, or it doesn't matter, there is what's called a stack. Okay? There's a stack memory in the computer program that keeps track of all the function calls. Every time you call a function, it push that function to the stack, and you keep stacking those function calls. So when you end the function, it can go back and remove those from the stack. And then that's how it also knows and tracks where the function was called from, and so forth. Okay. So to really explain this, here's an example of that. So instead of having the same function call itself, because it's so hard to understand, I'm going to use like 3 functions here, A, B, and C. Okay. And then over here on the left and right side, I have a stack. The stack here is a memory in a computer that keeps track of all the function calls. Okay. So right now, at the very bottom of the stack, think of this like a stack of dishes. Okay. At the very bottom is the empty stack. I put a bracket here to show that it's empty. And then over here is the output. Okay. So when you make the very first initial call to A, okay, so I make that function call A, and then now this is the active function, and the first line is going to print A, so the output we're going to see is A over here. What happens is that when you call the function A, it's going to push that function A up the stack or down, you're going to call it down, but into the stack, and then that's the active function until the function is done. Okay, so we print A to the output. The next line now we call B, right? So what happens when we call B? That is now jump over here now. So we haven't called this print A done yet because we moved over here now. So when you call B, so it pushes B function to the top of the stack. Okay, and then it prints B over here, and then it does the same thing. The next thing we call C, and it keeps going. So you see the stack is piling up here. Okay, and then we print C. C has two print functions only. So we see C and the C done. After that, C is completed, right? There's no more functions to call, no more data to perform. So it needs to go back to where it was called from. So that is going to go back down to B. Okay, when we go back down to B, because we reverse it back to where it was called from here, then it popped the function C call from the memory stack. Okay, so it's now gone. But then when we come back to C, then after C, there is another statement called print B. Okay, so that's the internal step 5 here. It will print B done over here. Actually, this is not there yet. It shouldn't be there. So we print B, and then B is done. So we go back to what B was before. So this is just telling you that it's still keeping track of the memory of where it was called from. And then we backtrack that way, and then it goes to B, and then we pop off B from the memory stack, and then we go back to A now. We print A is done, and then when A is printed, and then we move back to where it's being called from, we will get rid of A of the stack, and then everything is done. And in terms of the stack, so there is a limit to how many functions can be pushed to the stack. I think Python has about maybe 900, almost 1,000, stack slots only. So if you call a function 1,000 times, then it's going to overflow the stack, and that's here the term stack overflow. Okay, when stack is overflowed, your program crashes, and then it's done. Okay, so you don't want to do that, so you don't make that many calls. Of course, you can also increase the stack if you want to do that, but I mean, we don't want to do that because it consumes a lot of memory. So that should not be the option.